3.9, proving trigonometric identities. All right, so proving or verifying an identity means to show that both sides of the equation are the same. To prove an identity, simplify one side of the equation until it is equal to the other side. All right, so the trick to doing this is work with the side that is more complicated looking. All right, so example 1, we're going to prove that cosecant of theta times cosine squared of theta, typo, plus sine of theta is equal to cosecant. Alright, so this left-hand side is definitely more complicated, so I'm going to work with that one. So I know that cosecant is 1 over sine of theta times cosine squared of theta plus sine of theta. So I'm going to do this multiplication here. I'm going to get cosine squared of theta times sine of theta plus sine of theta over 1. So I need to make common denominators so I can condense further. So sine of theta times sine of theta. Alright, so I'm going to get cosine squared of theta plus sine squared of theta all over sine of theta. So, if I look at this, cosine squared of theta plus sine squared of theta is a Pythagorean identity. So, this is equal to 1. So, I'm going to get 1 over sine of theta. We know sine is the reciprocal of cosecant. We get cosecant of theta, which is what we wanted. So left side equals the right side. Example 2, we have sine squared of theta divided by cosine theta is equal to secant theta minus cosine theta. So this left-hand side looks more complicated. So we'll work with that. Alright. So I'm going to look at this top here, and I see sine squared. So I think of my Pythagorean identity. So cosine squared of theta plus sine squared of theta equals 1. If I move cosine over, I get sine squared of theta is 1 minus cosine squared theta. I'm going to substitute that back in. Alright. So now I want to break this up into 2 fractions. Pull it apart, 1 over cosine theta minus cosine squared of theta over cosine theta. These cosines will simplify. So I get 1 over, actually, I have to write that. I know 1 over cosine is secant. So secant of theta minus cosine of theta. And that is what we wanted. So we are done. Example 2. Some of them are really easy and flow real nice. Some of them take a little longer. Example 3. Cosine squared of theta is equal to sine squared theta times cosecant squared theta minus sine squared theta. Alright, so I am going to work with this right hand side because it's all crazy looking. Let me get my notes so I don't screw up. So first thing I'm going to do is I'm going to attack that. I'm going to flip that. So I'm going to get sine squared of theta. Reciprocal of cosecant is sine, so times 1 over sine squared of theta minus sine squared of theta. Alright, so for my next step, I have to multiply this out. And that gives me 1. Right, so the signs will cancel out, so you get 1 minus sine squared of theta. Again, if I look at this, look at my identities, I have sine, well, let's stay consistent. I've been writing cosine first. So cosine squared of theta plus sine squared of theta equals 1. If I move the sine over, I get cosine squared theta, 1 minus sine squared theta. So this equals cosine squared of theta, which is what we wanted. So we're done. Alright, example 4. We have tangent of theta is equal to secant theta divided by tangent theta minus tangent theta divided by secant theta. It has to equal cosine. So yes, the left-hand side is the ugliest, so we will work with that. Okay, so in order to combine this fraction in parentheses, I need common denominators. So I am going to multiply this by secant theta and this by tangent theta. So I'm going to get tangent theta times secant squared theta minus tangent squared theta. All divided by secant theta times tangent theta. Okay. I know the top here is another Pythagorean identity, and this equals 1. So this leaves me 1 over secant theta tangent theta. If I look at this, tangent crosses off with tangent. So I'm left with 1 over secant theta. And if we flip that, I'm going to get cosine of theta. Example 5. Cotangent squared of theta is equal to cosecant squared theta minus cosecant squared theta times sine squared theta. Alright, so when you're doing all these, don't forget PEMDAS doesn't go away. That's why you learn it in Algebra 1. So I'm going to attack this right hand side. Alright, and looks like I want to factor out that cosecant. So I'm going to get 1 minus sine squared of theta times cosecant squared of theta. And this identity right here, we've seen this a couple times already. That'll be cosine squared of theta. So now we're trying to get the cotangent. Cotangent is cosine over sine. So if I look at cosecant, I know cosecant is really 1 over sine squared. I'm going to get cosine squared of theta divided by sine squared of theta. And cotangent is cosine over sine, so cotangent squared must be cosine squared over sine squared. Six. Tangent of negative theta times sine of negative theta plus cosine of negative theta is equal to secant. Alright, so this is where you use your odd, even properties. So number 6, tangent of negative theta is negative tangent times negative sine theta. Yeah, plus cosine. So I'm just using the properties of the identities that were given earlier. Alright, so our next part is I see negative sine theta over cosine theta times negative sine theta plus cosine theta. Alright, so I'm going to work right here. So negative negative makes positive, so I get sine squared of theta over cosine of theta plus cosine over 1. Need a common denominator here. So I get sine squared plus cosine squared all over cosine. Again, this identity pops up again, so it's 1. So we're left with 1 over cosine theta. If we flip it, we get secant theta. Okay. 7. Alright, so 7, I got 1 plus sine squared equals 1 plus cosine squared over 1 plus cotangent squared. Alright, so I'm going to look at this right hand side. So we wrote it. Looks like I copied it wrong. I'll look at my notes. This should be cosecant, not cosine. It's cosecant. Sorry. Sorry, took me a second. Gotta breeze through those notes there. Alright. Which now I can use reciprocals and stuff like that. So I get 1 plus 1 over sine squared. And I got 1 plus cosine squared over sine squared. Okay, over 1. Need some common denominators. So this needs sine squared, sine squared, sine squared. Okay. I'll get sine squared of theta plus 1 over sine squared, all divided by sine squared plus cosine squared theta over sine squared theta. And this one equals 1. So I'm going to flip and multiply here. I have sine squared plus 1 times the reciprocal. So I have sine squared theta on top over 1. Signs cancel out. So I'm left with sine squared theta plus 1, which, if you use a reflexive property of addition, is 1 plus sine squared theta. Example 8. Sine theta plus cosine theta is equal to secant theta plus cosecant theta all over tangent theta plus cotangent theta. Alright, so we'll work at the right side here. You know, secant is 1 over cosine plus 1 over sine divided by tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. Need common denominators. So this side gets sine. This side gets cosine. This side gets sine. This side gets cosine. Crazy looking. So sine theta plus cosine theta over sine theta cosine theta and we get sine squared theta plus cosine squared theta. It's nice when you see that because we know it's going to cancel out nicely. Alright, just in case you don't know yet, you haven't seen the pattern, I'll know that equals 1. I'm going to flip here, I'm going to multiply. And it should cause some things that cancel out. So 1's on top in this bottom fraction, so it's going to go to the bottom. Sine times cosine cancels out with sine times cosine. So we're left with just sine theta plus cosine theta. Very nice. Two more to go. Example 9. Take a second, read it. All right. Crazy side. Looks like the left-hand side. Yeah, so I'm going to work with this left-hand side here. Okay. So, let's make common denominators. So, the right-hand side needs 1 minus cosine. Right-hand side needs sine. So I'm going to get sine squared theta plus, so that's 2 1 minus cosine, so 1 minus cosine theta quantity squared, all divided by sine theta times 1 minus cosine theta. Okay. So this one needs to get foiled out right there. So let's FOIL, get 1 minus cosine theta minus cosine theta plus cosine squared theta. Get 1 minus is 2 negative cosine, so 1 minus 2 cosine theta plus cosine squared theta. That goes back in. Becomes plus 1 minus 2 cosine theta cosine squared theta. Looks crazy. You gotta take a breath, look at it, and you see that something nice comes out of this. If you look, you get sine squared plus cosine squared. Remember, sine squared theta plus cosine squared theta equals 1. Alright, that's good. So we'll write 1 plus 1 minus 2 cosine theta over sine theta okay, so you get 2 combined like terms, not plus. Just copying, sorry. Alright, so 2 minus 2 cosine theta. Let's think factoring. Let's pull out a GCF of 2 on top. So I'm going to get 2, 1 minus cosine theta over sine theta, 1 minus cosine theta. Oh, both in parentheses. That means they both cancel out. Get 2 over sine theta. And what are we trying to get? We're trying to get cosecant. Well, just so happens that the reciprocal of sine is cosecant. Boom. Done. And you plan on taking pre-calc next year, you're definitely gonna need this stuff. Alright. Last example for the rest of the school year. Cosecant theta plus cotangent theta squared should be equivalent to 1 plus cotangent over 1 minus cosine theta. I'm gonna work with the right hand side. Alright. So did I copy this down wrong again? I think I did. Yeah, this is supposed to be cosine. Sorry. There we go. Should be 1 plus cosine theta over 1 minus cosine theta. What I'm going to do is I'm going to multiply top and bottom by 1 plus cosine theta. It's kind of like doing the conjugate when you're trying to rationalize the denominator. I want to force some things in the bottom to cancel out. So we got some foiling to do here. Top, I get 1 plus cosine theta quantity squared. And bottom, do my scratch work up here. Okay, first, I get 1 plus cosine theta, and I get minus cosine. And the last one, minus cosine squared theta. Middle terms cancel out. So we'll have to look at 1 minus cosine squared theta. That will go on the bottom. Which also so happens to be an identity. Alright. Sine squared theta plus cosine squared theta equals 1. Pull that over. You get sine squared theta is 1 minus cosine squared theta. So you get 1 plus cosine theta, quantity squared over sine squared theta. Since both of these have squares there, we can say this, 1 plus cosine theta over sine theta, quantity squared. And pull the fraction apart in the parentheses. You got 1 over sine theta plus cosine theta over sine theta squared. One over sine is cosecant, which is, if you look at the beginning, it's where we want to be. And then cosine over sine is cotangent. Quantity squared, which is what we wanted. And that is it, ladies and gentlemen. Okay. Good luck. This is not easy, but take your time. Hit me up with questions if you need them.